So hi everyone, welcome to Organ Technology Part 16. Today we're going to be talking about sound reproduction, and that's going to be our lead-in for an in-depth discussion over several episodes about speakers and the specialized speakers that were used on early analog organs. But first, please take a look at this. On my YouTube channel, you will find a variety of video products, including my arts and entertainment video podcast, Other Stages. Other Stages features music, stories, and thoughtful conversations with guests from across the entertainment spectrum. Also on YouTube, you will find my music videos that feature my original work and the classical repertoire. The Organ Technology series explores the fascinating ways in which organs have been built through history. You can sponsor my YouTube channel by joining me on Patreon, where you will receive exclusive Patreon-only content as a thank you for your support. You can also support my work at Venmo and PayPal, and you will always find these links in the video descriptions. My YouTube channel is not monetized and does not receive any financial support from advertisers. So just like PBS, I rely on people like you. Thanks. So back in the mid-1980s, I briefly worked for an organ dealership up in the San Francisco area. John and his partner Bill ran this wonderful store. We sold a particular brand of church organ and other types of organs. And one weekend we were doing some business conference thing, and on Friday evening when I got into town, we went to John and Bill's house, and they took me down into their beautiful basement where they had a lovely antique bar, and we had some cocktails, and we were listening to some vintage recordings on a vintage console record player system. And as I was listening, I asked, these are old shellac 78s, and I have a number of those at home, and mine don't sound this good. What's the deal? Well, the records and the players were all Bill's collection. That was his hobby. And he explained several things to me. It started with, well, are you playing them on a conventional turntable with a conventional stylus? And I said, well, yeah. He said, well, there's your problem. That's the first problem. The stylus shape for a hi-fi recording is wrong for a old shellac recording. So you have to get a special stylus to go into that cartridge. But then the problem is that the equalization curve of a hi-fi system, which is, if it's a good hi-fi system, nice and flat, that's not going to produce the sound on those recordings accurately. So this led to a tour of Bill's wonderful antique phonograph collection and his collection of antique phonograph recordings. He had over 10,000 recordings. And of course it was multiple genres of music, it was lectures, it was comedy, it was instructional stuff. And not only did he have the entire collection organized by genre and artist, he also had it organized by era of recording and the appropriate playback machine for those particular recordings. So if we go back to the earliest days of phonograph recordings, of course we have the Edison cylinder. And Edison, it was 1870 something when Edison invented the first phonograph. Audio recording was actually done prior to that in France, but it was done in a way that you kind of got the recording, but you didn't have the playback, and it was really as an experiment to see if you could capture and store the wave shapes of sound as they rolled through the air. So Edison does rightly get the credit for the first functioning record and playback system. The discs, of course, or the cylinders, of course, led to discs. And then, of course, there was the patent issue that Edison and the Victor Company got into. Edison, of course, was using his cylinders. The Victor Company comes along and they introduce a disc, but the Victor Company also did something slightly different with how the recording was made and played back, and that earned them a unique patent, rightly or wrongly. Well, the distinction was that the Edison system used a hill and dale. So, say this is your recording substrate, and this is the diaphragm on which the needle is mounted. As you spoke, it went up and down, cutting a hill and dale groove into the recording substrate. The Victor Company comes along and said, well, let's just do that differently. So instead of using a cylinder, they used a disc, and then they set it all sideways, and then the groove was cut side to side. And that simple distinction earned them a unique patent. Edison, being Edison, dug in his heels and continued to use cylinders and hill and dale. Eventually, he had to convert to disc because discs were winning, and then eventually the side-to-side groove that the Victor Company had patented won out. But of course, those first recordings were purely acoustic, and if you went into a recording studio, it might be a small room like this, and then in one corner you'd have this great big megaphone that was funneling the sound down to that diaphragm with the needle. And the singer would get right in front of the megaphone, and then all these instruments would be right around his head, and they would make as much noise as they possibly could into this megaphone. And then the sound pressure alone was what would cut the groove into the recording substrate. Then, of course, you made copies of those recordings and sold them to the public. And then it was, of course, an acoustic machine, the gramophone, that reversed the process. You had a diaphragm attached to a needle, and then that funneled into a conical horn, and then you could listen, and faintly in the background there was the sound of the recording. Well, acoustic recordings made minor progress over the next several decades, and by the end of the 1920s, Westinghouse came up with an electric recording system. And so instead of having the megaphone funneling sound down to the diaphragm that was going to cut the groove, what they did was replace that with a microphone and an amplifier, and then an electromagnetic cutting head that would carve the groove into the recording substrate, usually a hard wax. This was, of course, a tremendous improvement in fidelity. The frequency response was wider. You got a higher amplitude cut into that recording. But it also meant that the playback machines had to be capable of taking advantage of those new electric recordings. And interestingly enough, this is the late 1920s, and electronic stuff is still frighteningly expensive. So while Westinghouse had revolutionized the recording process, it relied on acoustic playback. But those playback machines had to be a little more sophisticated to handle the increased frequency response. This involved primarily an exponential horn being attached to the diaphragm so that those higher frequencies would come out. And that lasted for 2 or 3 years. By the 1930s, electronic recordings were matched with electronic playback. But still, you had to deal with the limitations of not only that early electric recording system, you also had to deal with the limitations of what you could get out of that shellac substrate. Shellac is a fairly coarse grain, and so there's only so much detail you can press into it accurately. The higher the frequency, the more detail it is in the recording process. Shellac just runs out of response at some point. Well, then we get to the 1940s, World War II. After the war, a lot of new materials are out and available, and we get into the era of vinyl records. And vinyl is a super fine grained substrate. You can put a lot of detail in it. So you could slow it all down. And you didn't have to go as fast. You could get more time. And you could put more detail pressed into the groove. And so the possibility of true hi-fi recordings became available. By the late 1950s, of course, we have true hi-fi stuff being recorded. We have true hi-fi equipment available for your home if you can afford it. And all of this brings up that evolution, right? Each process had its strengths and its weaknesses. And so the strengths and weaknesses of the recording had to be matched with similar strengths and weaknesses in the playback system. So back to that time in the basement bar listening to that old vintage phonograph system. These were records that were made in the late 1930s and 40s, and they had a particular equalization curve that emphasized the strengths of the recording and would de-emphasize the weaknesses of that recording. Specifically, of course, the highest frequencies just weren't going to be there, and you would have the surface noise of that needle on that shellac substrate running along. So the EQ of the amp and the speaker system would go along until you reached the high point of what a shellac record was going to do, and then roll that off so that you're going to filter out all of the negative aspects of that old shellac recording. So that made for a very different experience for me, and this was the first time that I learned about how different playback systems were really necessary to make these different recordings work. Once we get to high fidelity vinyl, you might think, oh, well, vinyl's the perfect substrate, everything's all hunky-dory now, and we're not going to have to do any playing around or manipulate the playback system in any way. Just make it as hi-fi as possible and off you go. Well, not exactly true. On vinyl recordings, there are a couple of quirks about vinyl, especially when you're dealing with stereo, that you have to compensate for. Now, vinyl is going to produce high frequencies in a spectacularly good way, but low frequencies at high amplitude will cause the needle to jump out of the groove. So what is done on vinyl records is you cut the low frequencies by 20 decibels. Then, to compensate in a way that's going to reduce the surface noise and take full advantage of the high frequency response of vinyl, you boost those high frequencies 20 decibels. So you get this linear equalization that is recorded into the vinyl recording. Then that's why your turntable has to go through a special preamp. The preamp does the opposite. It does a 20 dB boost on the bass and a 20 dB cut on the high frequencies. Now the net result is flat, and the needle's not going to jump out of the groove on strong bass notes. And you have, while you've cut out the surface noise of the needle rubbing against that vinyl, you haven't lost the high frequencies because you boosted them 20 decibels when you made the master recording. The other thing about vinyl records is when you went to stereo, the other thing you had to compensate for was bass frequencies. I think it's below 100, don't quote me on that, that may not be the exact number. But anyway, those lowest bass frequencies have to be mono. You can't do those in stereo because, again, the needle will jump out of the groove. So this really drives home the point that every recording process has its strengths, its weaknesses, and the playback system has to compensate for those strengths and weaknesses. Movie sound went through a similar evolution. The earliest movies and that first use of optical soundtrack, there's nothing wrong with an optical recording system, but the gear that they were doing it with at the time had a lot of limitations. Then as you go through the decades of sound moving pictures, you have improvements to that. You finally get to the 1970s, and George Lucas makes Star Wars. It's still being done with the refined but still relatively lo-fi movie soundtrack. And he hated the way that movie sounded so much that he built his company, Skywalker Sound, and they designed the THX sound system, which was a fully digital audio recording and playback system, so that the sound of a movie could be up to par with the kind of recordings we were playing at home on our turntables and hi-fi systems. And then, of course, when you watch Empire Strikes Back, the whole thing was done with the new THX sound. Kind of side by side with that at more or less the same time, Dolby Laboratories, famous for their cassette tape noise reduction system, also came out with a digital sound system for movies. You can hear the difference if you have a newer DVD copy of the original Star Wars Episode 4. You'll notice that while they re-recorded it THX, the original recordings of the orchestra playing John Williams' wonderful score were all hi-fi. The sound effects were all hi-fi, and they come out brilliantly on the THX sound. But the dialogue, which was recorded on set using the old optical sound system, sounds a little bit muted by comparison. And you can hear the difference between old movie sound and the new THX sound system. Now, how does any of this relate to analog organs? Well, here's the thing. The earliest attempts at synthesizing pipe organ sounds had their strengths and their weaknesses, and the audio equipment used to reproduce the sound of those instruments had to conform to those strengths and weaknesses. So I'd like to start out, now that we're going to get fully into this discussion of analog organ speakers, I'd like to start out with this little newsreel clip from long ago when the Hammond organ first came out, and it's going to explain how the Hammond organ's tone wheel system works, and it's a better explanation than I could ever put together. And I think I've shown this before, but it's worth seeing again.
Without pipes, without cumbersome air pressure apparatus, half the size of a grand piano, yet able to do almost anything that a huge church or theater organ can do. Amazing? Yes, and here's the secret. A simple device called a tone wheel, revolving in front of a small magnet. As these projections or bumps on the wheel pass the magnet, electric impulses are generated and a sound is heard in the loudspeaker. Turning the wheel produces a continuous note. The more projections on the wheel, the higher the note. This is the complete tone generator unit. Science has found that all musical sound consists of fundamental tones plus harmonics or overtones. The inventor here has supplied 91 tone wheels which, ingeniously connected with the keyboard of the console, produce any desired note or tone in the musical range. Here's a simple fundamental tone. The organist adds the proper overtones by connecting additional tone wheels, and we have the sound of a horn. Another combination of overtones gives us a sound like a bell. Thus, instead of great banks of pipes to imitate different instruments, simple keyboard connections with the proper group of tone wheels produce the rich musical variety of a massive old-time organ, as demonstrated in Mr. Paul's playing of Handel's Largo.
So as it was explained in that little newsreel clip, each of those tone wheels produced really a fundamental tone. When you combined them together at different pitches, you got the effect of additive harmonics. And that's what the drawbar system was all about. You could, as they showed, combine the 8-foot fundamental with the 4-foot and the 2 2/3 and get a horn sound. I've explained this before, that, a stopped flute on a pipe organ is basically a strong fundamental and a good solid amount of the third harmonic, or 2 2/3 in organ pitch nomenclature. So the Hammond was really an elemental synthesizer. And so each of those wheels was just putting out a sine wave at that particular pitch. But the Hammond organ had a glaring flaw that was seen as a big, big problem, but oddly enough would later be exploited by musicians for good musical effect. The tone wheel generator is running constantly. So all of those pitches are going out into what are called the key combs. And so it's ultimately a mechanical connection that connects the audio output of each of those tone wheels over to the amplifier and speaker. And of course, anytime you have a mechanical switch clapping together on an audio signal, you hear the amplifier is going to amplify that little bit of arcing that occurs right when those wires get close together. And so this created a phenomenon called key click in the Hammond. So right off the bat, the speaker system had to be designed in such a way as to reduce that key click as far as possible. And the way Hammond did it was the preamp that was inside the organ rolled off at 6,000 hertz. Then the tone cabinets were built in such a way that the speakers would have a sharp roll off, practically a cutoff, at 6,000 hertz. And this was one of the first times that the speaker system was used on an organ to filter the sound to be more realistic or more approximate to that of the pipe organ for which it was trying to imitate. So I looked up a bunch of pictures of Hammond tone cabinets, and they're these big furniture style boxes. A lot of them have just a couple of like 10 or 8 or 10 inch cones at the top going down into a big boxy chamber and then spitting sound out the side. You'll see in some of these pictures that, on the backside you see just a bunch of, fairly sizable cones. There's not a tweeter in sight. You've got, all vacuum tube amplifiers in these things. And these were absolutely necessary to produce the sound that the Hammond Company wanted you to hear once it was all said and done. So, because those tone wheels only generated the fundamental tone, they didn't really generate much in the way of harmonics. Using the speaker as a filtration system just to knock off that key clicking was a fairly simple thing to do. But of course, what followed right away was the first oscillator-based organs. I think it was 1937 that the first audio oscillator was patented, and this was followed by the production of oscillator organs. Now, oscillators, unlike your tone wheels in a Hammond organ, do generate harmonics. And some of those harmonics you want, and some of those harmonics you don't want. So right away, in addition to building the organ with oscillators instead of tone wheels, you also had to have filter circuits built in to try and remove those unwanted harmonics from the oscillator tone. And once again, the type of speakers you used were critical to the final filtration and realism of that sound. Those early filter circuits did some of the work, the speakers did the rest of the work. And again, it came down to doing a very similar thing to what Hammond did, was find that cutoff point. What's the highest pitch that the organ is actually going to produce? Well, my speakers don't really need to produce anything above that. So let's have the speaker system cut everything off at that point. This is true up to a point, but obviously certain organ tones, especially reed pipes, are going to produce frequencies into that hi-fi spectrum. So that's why as we get later in the analog era of organ building, the filter circuits have to become increasingly sophisticated so that the speakers have to do less of that filtering so that you have more of those high frequencies available to produce those reed tones and string tones more accurately. So that's our little introduction into organ speakers. Now, next time, what I'm going to talk about is animation. That's the other glaring flaw that the Hammond organ and early oscillator organs had, was the lack of multi-rank ensemble. And a guy named Don Leslie came up with an incredibly clever solution to that. He rotated a speaker to get a chorus effect and then rotated it faster to get a tremolo effect. And there were variations on the Leslie speaker that came out, and for the same reasons, trying to get around Don Leslie's patent. So at any rate, that's it for today. I hope you've enjoyed this. I certainly enjoy making these videos and doing the research and coming up with the information for you. Anyway, we will see you next time.